Welcome to GER Hub Mathematics and Statistics lessons. Today I shall be talking about matrices and determinants part 3. In this video I shall consider addition and subtraction of matrices and shall be answering two questions. When can one add matrices or subtract one matrix from another? And two, how do we add matrices? So let's start with the first question. When can we add two matrices together, or when can we subtract one matrix from another? So I'm going to start with giving a simple condition. So let's start with a simple description. Two matrices are conformable for addition or subtraction if and only if both matrices are of the same order. So if two matrices must add one to another, or two matrices must have one subtracted from the other, then it is compulsory that those two matrices must be of the same order. So if two matrices are not of the same order, it means they cannot be added or one cannot be subtracted from the other. Okay? So when are two matrices conformable? The word conformable means agree. When do two matrices agree for addition or subtraction? They only agree for addition and subtraction if and only if both of them are of the same order. So let us consider an illustration. Let A be a matrix. Let A be a matrix of order m by n. Okay? Let B be a matrix of order P by Q. Then A and B are only conformable for addition or subtraction if and only if m by n is equal to p by q. And what does this mean? It means that if A is a matrix of order m by n and P is a matrix of order p by q, then both of them can only add provided the order of A, which is m by n, is equal to the order of B, which is p by q. Okay? Now, what does this mean? If the order of the matrix A, which is m by n, is equal to the order of the matrix B, which is p by q, then it means that m is equal to p. And if m is equal to p, it means the number of rows in A must be equal to the number of rows in B. This also implies that n is equal to q. So the number of columns in A must be equal to the number of columns in B. Now, what did we say earlier? Two matrices are conformable for addition, and the word conformable means agree. Two matrices agree for addition and subtraction or subtraction if and only if both matrices are of the same order. Now, if we take two matrices particularly of order m by n, that is A, and of order p by q, that is for B, then A and B are only conformable for addition or subtraction if and only if the two orders are the same, meaning that the order of A, which is m by n, is equal to the order of B, which is p by q. And from this relationship or this equation stems this statement, or the implication stems and is derived from this. Okay? If m by n is equal to p by q, then it means that m, the number of rows in A, is equal to p, the number of rows in B. And this also means that m N, the number of columns in A, is equal to Q, the number of columns in B. Now, what is the implication of this? What is the implication of these two statements? The statement means that a 3 by 2 matrix cannot add to a 2 by 4 matrix. You cannot add a 3 by 2 matrix to a 2 by 4 matrix. You cannot add a 1 by 3 matrix to a 4 by 1 matrix. So why can't you add this matrix to this matrix? And why can't you add this matrix to this matrix? Why can't you subtract a 2 by 4 matrix from a 3 by 2 matrix? And why can't you subtract a 4 by 1 matrix from a 1 by 3 matrix? It is simply because the two matrices are not of the same order. So if I have a matrix A, which is of order 3 by 2, and I have another matrix B, which is of order 2 by 4, both of them cannot add. If I have a matrix A 3 by 2 and a matrix B 2 by 4, both of them cannot be subtracted one from another, simply because they are not of the same order. Okay? So if A must be added to B, they must be of the same order, meaning that A 3 by 2 can only add to B 3 by 2, and A 3 by 2 can only have B 3 by 2 subtracted from it. So two matrices are conformable for addition only if they are of the same order. So take note of that, and let us take the following examples. So let me bring this here as an illustration. Okay, so let's see. Now, if I have a matrix A that is a 3 that contains 3, 4, 5, 6, and I have another matrix B that is 6, 2, 1, 0. Now the question is, are these two matrices conformable for addition? Yes, the answer is a very big yes. Both matrices are conformable for addition. Why are they conformable? It is simply because A is of order 2 by 2, it has 2 rows and 2 columns, and B is of order 2 by 2, it has 2 rows and 2 columns. Now, that is the reason why both of them can be added one to another, or one can be subtracted from the other. If I give you another matrix, another pair of matrices, okay? If I give you a matrix C of order 3, 2 by 2, having 3, 2, 6 as the elements, and another matrix D of order 3 by 2, okay? Now, can these two matrices add to each other? The answer is a big no. They cannot add to each other, simply because the two matrices are not of the same order. They can only add one to another if they are of the same order. So this is not conformable with this for addition, neither is it conformable with this for subtraction. Why? This matrix is of order 2 by 2, and this one is of order 3 by 2. It has 3 rows and 2 columns. This one has 2 rows and 2 columns. So they cannot add to themselves. Okay? So when are two matrices conformable for addition? Only when both of them are of the same order. Now, let us quickly see the next thing I want to talk about. So, the next question. The next question in this video answers the question, how then do we add two matrices that are conformable for addition? So, now that we have said that two matrices are conformable for addition if they are of the same order, if we are presented with two matrices, how then can we add them if they are conformable? So I'm gonna start with making a statement. I'm gonna start with making a statement here. To add two matrices, to one another requires that we add elements occupying similar positions in both matrices. Okay, so if you must add two matrices to one another, then we are required to add the two elements, any two elements occupying similar positions in both matrices. So let's see, if I have a matrix A equals A11, A12, A21, A22, that is a 2 by 2 matrix. Now, and I have another matrix B, which is equal to B11, B12, B21, and B22. Now, this is also a 2 by 2 matrix. Clearly, both of them are conformable for addition and subtraction, simply because 2 by 2 is the order of A, which is equal to the order of B, which is 2 by 2. Okay? So, if I am required to add A to B, then it is possible to do so because they are of the same order. But here, the question is, how do we do that? For you to add two matrices that are of the same order, that is two matrices that are conformable for addition because they are of the same order. Now, this is A11, A12, A21, A22 of the matrix A. This is B11, B12, B21, B22 of the matrix B. Now, if both of them are clearly conformable for addition, then all we have to do to get the addition of A to B is to add elements occupying similar positions. Note that A11 occupies the same position as B11 in both matrices. That is, it occupies the first row, first column, just like B11 occupies the first row, first column. So this would mean adding A11 to B11. A12 and B12 occupy the same position, so I can add A12 to B12. A21 will add to B21, and this becomes A21 plus B21. A22 will add to B22, and this becomes A22 plus B22. Okay? So to add matrices is simple. All you have to do is to add elements occupying similar positions. So this will add to this. This will add to this because they are occupying similar positions. This will add to this, and this will add to this. Okay? So adding matrices is not a big deal. Now let us go over to subtracting A or subtracting B from A. If I were to subtract B from A, then I would do the same thing. The rules remain the same. This is A11, A12, A21, A22. This is B11, B12, B21, B22. So all I have to do is to bring my result here. If I'm subtracting B from A, then A11 minus B11 would come in here. A12 minus B12. Now, why this is happening is because both elements I'm taking are of the same order. So this goes to this, okay? And this goes to this. This will go with this, and this will go with this. So this becomes A21 minus B21. This will be A22 minus B22. Okay? So adding or subtracting matrices simply requires you to add elements occupying the same position to one another, or subtract elements occupying the same positions from one another. Okay? So let's take a very concrete example. Let's take a quick example on how to do that. Now, if I give you the matrix A equals 2, 4, 6, 8, and another matrix B equals 6, 2, 1, 5. Clearly, these two matrices are conformable because this is 2 by 2 and this is 2 by 2. So if I'm required to produce A plus B, all I'll do would be to add the following. I would add 2 to 6 and that gives me 2 plus 6. I'll add 4 to 2 and that will give me 4 plus 2. I will add 6 to 1 and that will give me 6 plus 1. I'll add 8 to 5 and that will give me 8 plus 5. Now, why am I performing this? Why am I adding 2 to 6? 2 occupies the first row, first column. 6 occupies the first row, first column. 4 occupies the first row, second column. 2 occupies the first row, second column. So elements occupying similar positions will be added. And finally, our result becomes 2 plus 6, which gives 8. 6 plus 1, which gives 7. 4 plus 2, which gives 6. And 8 plus 5 giving us 13. So our result for A plus B will be equal to 8, 6, 7, 13. Now, what if we were asked to find B plus A? Now, note that B plus A would require us to bring the matrix B first and then the matrix A second. So this will be 6, 2, 1, 5 for the matrix B, and then 2, 4, 6, 8 for the matrix A. That will give us, in addition, 6 added to 2 to give 6 plus 2, 2 added to 4 to give 2 plus 4, 1 added to 6 to give 1 plus 6, and 5 added to 8 to give 5 plus 8. So your final result becomes for this 8, 6, 7, 13. Now note one thing about the two results we have obtained. This is the result for B plus A. This is the result for B plus A, and it is clearly equal to the result we obtained for A plus B. Okay, so the result we obtained for B plus A is equal to the result we got for A plus B. Now this establishes a property called commutative property. So what it means, because A plus B would always give you B plus A, since A plus B is equal always to B plus A, then we say addition of matrices is commutative. So this property exhibited by matrix addition is called the commutative property, because adding a matrix A to B in one direction is equal to adding the matrices in the other direction. That is, if A plus B gives you B plus A, and for matrices A plus B would always give you B plus A. So we say that matrix addition is commutative. Okay, now let us go with this same example. Let us go with this same example to obtaining A minus B. So for A minus B, you would have 2, 4, 6, 8 minus 6, 2, 1, 5. What will the result be? This will be 2 minus 6, similar position. 4 minus 2, similar position. 6 minus 1, and then 8 minus 5. Okay, and the result becomes 2 minus 6 is minus 4, 4 minus 2 is 2, 6 minus 1 is 5, 8 minus 5 is 3. So the result we obtain for A minus B would be minus 4, 2, 5, and 3. What if we go over to B minus A to see if the commutative property also holds for B minus A? Now we are going to bring the matrix B forward. That is 6, 2, 1, 5 minus the matrix A, which is 2, 4, 6, 8. Now, looking at it, you would note one thing, that 6 minus 2 becomes what we have here because they occupy similar positions. 2 minus 4 comes over here. 1 minus 6 comes over here. And 5 minus 8 comes here. Now, what will our result be? Let's see. Our result will be 6 minus 2 gives us 4. 2 minus 1 and 2 minus 4 gives us minus 2. 1 minus 6 gives us minus 5. And 5 minus 8 will give us minus 3. Now note that these two results, the result we obtain for A minus B, the result we obtain for A minus B is not equal to the result we have obtained for B minus A. And what does that mean? It means that matrix subtraction is not commutative. Matrix subtraction is not commutative. So whereas matrix addition is commutative, matrix subtraction is not commutative. So thank you very much for watching this video. Like our video, share our video, and most importantly, subscribe to our YouTube channel. For question solving on matrices, please visit our videos on the solver series on matrices, and you will see a lot of problems solved on matrices. So these were just illustrations on a particular subtopic, matrix addition and subtraction. Please subscribe to our YouTube channel for more content, and I'll see you in a bit. Thank you.